new paper argues that the Great Filter may be sitting between artificial intelligence and when a civilization can send autonomous probes across the galaxy. If that's true, we as a species may be approaching the bit that keeps killing everyone.
I'm in trouble.
But I'm not sold on it. Hear me out. Here's the problem. A civilization wiped out by AI right before they send probes leaves exactly as many interstellar probes as life that never got beyond pond slime. None. So how could some missing probes tell us at which point everyone failed? In case you're not familiar, the Fermi Paradox is the question that if the galaxy has had billions of years, hundreds of billions of stars, and an absolutely unreasonable number of planets, then where the hell is everyone? The Great Filter is the idea that somewhere between dead chemistry and a civilization spreading through space, there's at least one step that almost nothing gets through. The question is whether that step is behind us or ahead of us. Sergey Ivliev's conceptual paper puts a possible late filter around the transition from AI to what he calls autonomous AI cosmo industry. The term sounds like a startup that raised $40 billion based on one PowerPoint, but the idea is simple. Once AI, robotics, and space manufacturing can work without a living crew, aliens don't need warp drives and giant colony ships. They can send small 10-kilogram machines that travel slowly, if by slowly you mean 1% of the speed of light, which is just under 3,000 kilometers a second, or 4 million possums nose to tail for every one Mississippi, in case you're metrically challenged. Then these automatons can use local materials to repair themselves and make more machines. There's an earlier argument that a rational AI would tell its owners that going to space isn't actually worth the cost. But Ivliev says doing this would be so cheap, it would be irrational not to. Its purpose could be scientific research, or it could be a backup for the species in the form of seeds or embryos, or preservation of their culture in the form of data about their history, science, art, and 4 billion hours of reaction videos preserved forever. Imagine finding a complete archive of an extinct civilization, and half of it is podcasts explaining how to become more productive. Ivliev estimates that a probe like this could help spread this kind of a system across the galactic disk in around 10 million years. That's a long time for us, but ridiculously fast for the galaxy. But it's also a long, long time for the species that sent it. Continents will have moved, there will have been a couple of mass extinctions, Alien GTA 7 will be in early access by then. So if any civilization crossed that threshold early enough, its machines could have reached the solar system by now. And we haven't found any.
We ain't found shit!
So according to him, the obvious conclusion is that civilizations keep failing somewhere between AI and autonomous space industry. That's what he calls the quiet expansion filter. A quiet expansion filter sounds like a setting on an air purifier, but to Ivliev, it means a murder corridor between inventing AI and sending the probes, which is now. So let's look for one of Ivliev's probes. The paper suggests searching the moon, asteroids, Trojan regions, stable orbits, and the outer solar system for artifacts or small industrial traces. Excellent! We have narrowed it down to space. Except if there's one, for example, in the bottom of the Pacific studying shrimp because it came from an ocean planet and the idea of intelligent land mammals is laughable to the species that sent it. So not even just space. The paper says quiet expansion could be sparse, selective, low power, and below current detection limits. So it's a possible explanation to why we don't see loud alien empires, but it doesn't mean quiet ones are or aren't there either. And the cheapness argument has a problem too.
Houston, we have a problem.
The paper calculates the energy required to accelerate a 10-kilogram probe without factoring in thousands of years of survival and collisions in space, repair, and manufacturing. Most importantly, it doesn't calculate braking, because if you want to mine something, you gotta stop for a while. More on that in a minute, it's a big one. And it has to have a way to steer itself. AI can detect if it's off course, but even a really, really smart computer can't get out and push. Estimating the launch energy and calling the whole expansion cheap is like looking up flights on Skyscanner and claiming you figured out the cost of invading France. To replicate itself, the probe has to stop, find materials, and rebuild a whole industrial supply chain from rocks, and neither the cost calculation nor the timeline take any of these into account. As for the purposes of a probe like that, I get scientific research. It could have a closer look at things telescopes can't see. Maybe it could even do crop circles and anal probes on hillbillies.
Moon River.
But then sending data back to a planet 100,000 light years away takes 100,000 years. And that's after 10 million years of travel.
We apologize for the delay.
So after 10.1 million years, would the species now living on the planet that sent the probe still be interested in the same stuff? Would they even know their distant ancestor species sent these things in the first place? That is, if anyone is even still there. And for preservation, I don't know, man. A probe carrying embryos probably shouldn't go very far. In case the planet has a catastrophe that wipes out the species, probably the best idea would be for the probe to stay kind of nearby and just wait until things cool down and the biosphere heals a little bit, and then bring the embryos back to start over on the planet that they evolved for. It would make a cool sci-fi story, but it wouldn't mean probes light years away from home. If it's to preserve the culture for another civilization to find, we've already done that. Voyager 1 and 2 are exactly that. And the fucking Tesla Roadster orbiting the sun is like the annoying toddler version of that. And none of them were sent to space just to do that. They were all sent up for a different purpose, and then a couple of things were added on board just in case some alien finds them one day. Ivliev calls archives, genomes, embryos, and seed systems a form of backup. But an artifact is not a population. If humanity died, having the car of the worst one of us orbiting the sun wouldn't make me feel any better. Having Perseverance on Mars isn't a backup, and a probe with a hard drive full of our films, songs, and podcasts wouldn't be one either. And aliens finding their Joe Rogan experience would probably conclude we're better off dead anyway. Ivliev calculates accelerating a probe like that to 1% light speed would take 12.5 gigawatt hours, which costs only around $500,000 to $1 million. That sounds amazing, but it's kind of like buying the gasoline for a car that doesn't exist. Because if you wanted it to stop at any point for mining, or replicating, or butt probing,
Am I harvesting farts? How much can I learn from an ass?
it either needs to carry that much energy with it, which would bring the weight way up, or it would have to have solar or magnetic sails, which would bring the weight up to several tons. There's a published sail design by Finnish physicist Pekka Janhunen that weighs 8.25 tons. Getting all that to 1% of light speed would take over 10 terawatt hours. That's roughly 590 Hiroshimas, or the energy to microwave 150 billion Hot Pockets. And that's at an impossible 100% efficiency. So for the energy alone, we're talking more like $1 billion. Of course, it could use the sails to accelerate as well, but I think that's a lot slower than what Ivliev had in mind. And that's before we powered a single computer or built the bastard, let alone put it on orbit, because obviously the acceleration is not the whole cost. Sending Perseverance to Mars cost $2.7 billion and took decades of labor. And Percy doesn't even have to build another Percy from Mars rocks. And if the probe replicates itself, then the new probe, the locally sourced probe, then needs 10 terawatts of energy of its own from somewhere. I'm starting to feel like this might slow down the expansion by a little bit. Try convincing a politician to fund the project when, if we sent one today to Proxima Centauri at 1% light speed, we would get the first images from there in the year 2455. There's the great filter for these probes right there. So what has the paper given us? Not the location of the great filter, not even a realistic thing we might build one day. It's just given us another possible sign of technology that SETI could search for, which makes it more like Freeman Dyson's original point than you might realize. Dyson wasn't telling us to build a sphere around the sun. All he said was that if advanced civilizations capture enough starlight, their waste heat could give astronomers something to look for. Ivliev is also giving us something to look for. But unfortunately, his version may be a switched off 9-ton lump pretending to be a rock somewhere in the Kuiper Belt, or a 10-kilogram bullet shooting through space taking blurry pictures. Radio SETI was looking for a needle in a billion haystacks. Dyson Spheres added a peanut to one of the stacks. Autonomous probes add a grain of dust. No, not that one, a particular one. So, yay? Now we have another thing to search for and almost no way to search for it. But I mean, it's still better than getting evidence that AI will definitely kill us all in the next few years. We still don't know if we've already passed whatever the great filter is, or if it's still coming, but we do know that we've passed a lot of filters. I've said it before and I'll say it again. There's no need for a great filter when a bunch of pretty good filters stacked on top of each other already makes it almost impossible for us to still be here. Anyway, I think what we can take from this paper, I don't know if it was Ivliev's intention or not, but it's not that we're all about to die, it's just that we're not done looking. Thank you for watching. There are buttons for liking, hyping, and subscribing below, and I'd really like it if you hit them like they owe you money. There's also a whole comment section waiting for you, and t-shirts and a comedy special to spend money on. All somewhere down here. See you in the next one, and in the meanwhile, here are some videos that YouTube would like you to see.
Be like finding a needle in a coal mine.
Haystack.
Oh, right. Haystack in a coal mine.